So let's quickly apply to problem 2. And problem 2 is analyze the fast food operation based on the process flow diagram drawn in problem 1. So we already draw that. If you are not sure, go watch the lesson video that involve with problem 1 and that I copied in down here. But with additional information, when one person A take orders, so take orders, person A, so that here, as you can see, this is person A. Person A here. So that this, again, this process diagram is from problem 1. I copied out there, problem 1. So this is person A. Take orders and 2 minutes per order, so that here you have it 2 minutes per order. And then one person B, only one person B, so this is person B, and that person B prepare the food for the orders and 3 minutes per order, so that with 3 minutes per order. And the question is analyze the fast food operation with that one. So as you can see now, we have the packaging, assume it's 0 minutes. It include everything in there, 0 minutes per order. And then of course, call to the orders, it's also 0 minute. It will be fast, right? Just call the number. Then it can be neglected the time. So with that one, we want to analyze this process by determine what is the bottleneck, what is the cycle time, what is the idle time, what is the capacity, what is the manufacturing lead time. So with that here, we go to do the analysis. The first is what is the bottleneck in this process. What is the bottleneck? As you can see, the person take the order only need 2 minutes per order, while the make a burger is 3 minutes. So the bottleneck, what definition here is the factor which limits production, and the factor limit production here is the make a burger is the limit. It take longer, so the order have to wait in here, right? So that one is the bottleneck. If we make the order like 2 minutes per order, then it will improve the productivity in this operation, improve the performance. So that for sure, that is the make a burger that fast is a bottleneck. And then what should be the cycle time? What should be the cycle time? The cycle time in here, definition, average time between the completion of successive units. So think about this operation, and you can see cycle time, what is the cycle time should be. 2 minutes, 3 minutes, or 5 minutes. Apparently, because the bottleneck is the making a burger, so it will control the productivity, the operation of this fast food operation. So every 3 minutes, it will produce one burger, as you can see here, not 5, because that separate process in there. So cycle time, the average time for between the completion of successive units. So in this case, you can see that it's 3 minutes. And those detected by the parts that have bottleneck, that make a burger. The next question is, what is idle time? Idle time. what is definition of idle time? The time when used for work not being performed. And you can see person A only take 2 minutes to order, while the person B make 3 minutes to order. So person A have some time to wait, and that consider idle. So in this case, person B wait for every order, wait for another minute, so that is idle. For 3 minutes, wait 1 minute, only do 2 minutes of order. So that why the idle time here, as you can see, the person 8 will be idle. One minute out of 3, so it will be 1/3 of the time. And the next for the analysis process here is what is the performance and manufacturing lead time. What is the performance and manufacturing lead time? So that is the last two we want to analyze in this one. So what is the capacity? And by definition of capacity, it is the maximum rate of output burgers per hour, for example. So with that one here, per hour, so you have 60 minutes per hour divided by the cycle time. Cycle time is 3 minutes per burger. So here, 3 minutes per burger, and we determine the cycle time. So from that, we can get that one equal to 20 orders or burgers, right, per hour. And that is the capacity. And the last one is what is the manufacturing lead time or throughput time. MLT or throughput time. So in this case, what is the definition? The last one. The length, time spent in the process, the length of the time spent in the process. So in this case, as you can see, let's see the order. Customer here, take the orders, and then order waiting in here, and go to make the burger for 3 minutes, take order 2 minutes. What should be the manufacturing lead time? The time, the length of the time spent in the process. So as you can see here, not the first order, but the from the second order, you can see that the order, it will take 2 minutes in the take orders, waiting 1 minute in the inventory orders, and then 3 minutes in making the burger, and everything else is 0 minutes. So that it will be the time spent in the process for each unit. In this case, not the first one, but from the second one, it will be 6 minutes, not 5 minutes, because it's waiting in the order here to the previous unit finish. So it order have to wait on average 1 minute. So with that one here, you can see that it will be 6 minutes. And again, let me see, not 5 minutes, as I explained earlier. So keep that in mind. So those are the few key measures to determine the process and process analysis.